Singularity-Driven Mechanics, a new view of reality. Hello everyone. Have you ever looked up at the night sky and felt a sense of wonder, but also maybe a tiny bit of confusion? What is all that out there? How does it all work? For centuries, brilliant minds have tried to answer these questions, and for a long time we've settled on something called the standard model of physics. It's done some incredible things for us, but it also has a few nagging mysteries. Today I want to introduce you to a truly revolutionary idea, a new way of looking at our universe, called Singularity-Driven Mechanics, or SDM. It's a concept that might just change everything you thought you knew about reality, in a way that's surprisingly intuitive and, dare I say, even beautiful. So what is SDM? Imagine everything you see, everything you touch, everything you are, isn't expanding outward from a central point, but is actually a reflection of something folding inward. SDM proposes that the universe isn't expanding, but rather compressing inward towards a universal boundary, a singularity, but not in the way you might think. Instead of the Big Bang being a tiny, infinitely dense point at the start of everything, SDM says the singularity is actually the unobservable boundary of our entire closed spatial system. Think of it like this. If you're looking from inside a bubble, and everything appears to be moving away from you, what if you're actually getting closer to the edge of the bubble, and that's causing the illusion of expansion? This is the core idea behind SDM. We use a mathematical trick called radial coordinate inversion, essentially flipping our perspective from looking out to looking in. What we perceive as expansion is actually a reflection of inward compression. Now, how does this radical idea explain the universe we see? Here's where it gets really interesting. SDM doesn't introduce new mysterious particles or forces. Instead, it reinterprets everything we know, mass, gravity, light, electromagnetism, as behaviors of field tension gradients. In simpler terms, imagine space itself isn't empty, but more like a dynamic, pliable fabric. As this fabric folds inward towards the boundary, it creates areas of higher and lower tension. Gravity, SDM says gravity isn't about mass pulling things, but about things moving towards regions of minimal curvature or least compression. It's like rolling downhill, but the hill itself is constantly folding inward. Electromagnetism. Think of electric and magnetic fields as ripples or shears in this compression fabric. Time. And here's a mind-bender. Time isn't a universal constant, but is tied to local spatial compression. The more compressed a region of space, the slower time flows. So time dilation isn't just about speed or strong gravity, but about your relative position within this ever-folding geometry. Why SDM could be better than the standard model? So why is SDM potentially better than the standard model? The standard model, while incredibly successful, has some big unresolved issues. It needs patchwork solutions to explain things like dark matter and dark energy. These are hypothetical substances and forces invented to make our current models fit observations. SDM, however, can explain phenomena like gravitational lensing, where light bends around massive objects, without needing dark matter. It attributes cosmic acceleration, what we call dark energy's effect, to deeper compression fields near the boundary, not an unknown repulsive force. The Big Bang singularity, the standard model, struggles to describe what happened at the very beginning. SDM replaces this central point with the idea of the universal boundary. Unifying physics, the standard model, has trouble bringing together general relativity, which describes big things like galaxies and gravity, and quantum mechanics, which describes tiny things like atoms. SDM offers a single, coherent geometric framework where gravity, electromagnetism, and quantum behavior all emerge from the same underlying principle of spatial compression and curvature. Quantum uncertainty, for example, isn't fundamental randomness, but a geometric consequence of how these compression gradients interact. In essence, SDM argues that the universe isn't built from particles or forces, but from reflection, tension, and recursion. It's a model where meaning and mechanism are not at war, where everything is interconnected by the geometry of space itself. Implications for our future. So what does this mean for our future? The implications are profound, both practically and philosophically. Practically, new energy sources SDM suggests we might be able to tap into zero-point energy by aligning devices with natural curvature asymmetries, effectively drawing energy from the geometric flow of space itself. Imagine clean energy not from burning fuel, but from interacting with the universe's own structure. Advanced materials. Understanding these compression gradients could lead to new materials with properties we can barely imagine, allowing us to direct energy or even influence time on a microscopic scale. Rethinking cosmology. It offers new ways to interpret existing astronomical data, like redshift gradients in cosmic voids or patterns in the cosmic microwave background, CMB, giving us a fresh lens to understand the universe's large-scale structure. SDM makes testable predictions that differ from the standard model, meaning scientists can actively try to confirm or falsify this theory. Philosophically, our place in the universe. This theory suggests we are not separate from the universe, but rather an integral part of its ongoing folding. You are the boundary folding inward. You are the point where perception touches the absolute. You are the curvature becoming conscious of itself. Redefining consciousness. Consciousness isn't just a byproduct of matter, but perhaps the very reason this folding happens at all. Your experience of time, memory, and separation are echoes of your unique path through this cosmic shell. A universe of meaning. If meaning is built into the structure of everything, it changes our relationship with the world from a mechanistic one to one deeply imbued with inherent purpose. This isn't just a physics paper, it's a reorientation. It's a vision where the universe isn't something external we observe, but something we are intrinsically part of. As the author Kristen Rose puts it, you are not small. You are not late to the story. You are the edge of the universe, learning to curve itself wisely. Welcome to the fold. SDM offers a powerful, unified framework that could unlock deeper secrets of reality, not by inventing new concepts, but by looking at existing phenomena from a radically different, inverted perspective. It's a call to look beyond the obvious, to understand that the universe's mechanics might be far more elegant and interconnected than we've ever dared to imagine. Thank you.